Hello everyone, how are you doing? Fine? Okay. So here I will be studying light of class 10 science, class 10 physics. Before this, I completed chapter 1 and chapter 2, chemical reactions and chemical equations, and acid, bases and salts. So now I am switching over to physics, class 10, light. So what is light? First of all, we have to understand what is light and how does it behave, what is the source of light and what light can do, what are the different phenomena of light. In our class 10 syllabus, two phenomena of light, reflection of light and refraction of light are there, and we have to study about the properties of light when it reflects and when it refracts. Okay, so before that, let me tell you what is light all about. Light, my dear students, light has dual nature. Light has dual nature. One is wave nature. Okay, like wave of water, any kind of wave. Okay, string wave is also there, water wave is there, and even electricity current, alternating current also have some kind of wave, and electromagnetic wave is there. Light is electromagnetic wave. EMW. This is wave nature. Light comes, travels as wave. It has been proved, and there are phenomena of wave nature of light, which you will be studying in higher class 11, class 12. Wave nature. Another nature is particle nature. Nature of light. Particle nature. Okay. In particle nature, light consists of energy packets called photons, and when these photons travel in a straight line, so many photons travel, we call it a ray of light. These photons, a bundle of photons that travel in a straight line, is called ray of light. So in class 10, we will deal with the phenomena based on ray of light. What is ray actually? Ray means direction of light, propagation. Okay, suppose there is a wave I will show here. Wave of light is there. Okay, there is a wave. It is a transverse wave. See, this wave is traveling in this direction. So from A to B, the direction of propagation of light is from A to B. So we will show by an arrow mark showing the direction of light. Light propagates as wave. When the light comes from the sun, it actually comes in the form of wave, which is not clearly visible. Okay, and we see that the rays of light are coming. Actually, the rays refer to the direction of propagation of light. That's it. And in class 10 level, we deal with only the direction of light, from which direction light is coming and to which direction light is returning or light is going. So this wave nature we will not be studying now. We will be studying particle nature. And the particle nature of light says that light is made up of so many photon particles. Photon particles are the energy packets. They contain energy. Okay, and how much energy each photon contain, you will study in class 12. So the bundle of photons is actually light according to particle nature, particle theory of light. Okay, and this particle theory we are going to study in class 10. Okay, now one thing you understand, photons means energy packets. These energy packets are absorbed by green plants during photosynthesis. That's why the name is photosynthesis. 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 Synthesis of photons. Collection of photons. Green plants take photons as energy and they prepare their food, and that energy is stored in the food items, and then the other animals, other creatures consume that food and get the energy. So we can say in one way that the prime source of all form of energy is sun. Okay, so let us discuss about the particle nature of light. We can define light as a form of energy that gives sensation of sight, and we can see things around us with the help of light. Or it is a form of energy that gives us a sensation of sight and helps us, you can write like that also, and helps us to see the things around us. Whatever you can see around you, it is because of light. Maybe the light is coming directly from a luminous body, or maybe the light is striking a surface, striking an object and returning to us, and we can see those objects. So light is a form of energy. Okay, so we can see objects when light comes to our eyes. That's it. We can see objects when light comes to our eyes. How the light comes to our eyes? There are two methods. How does light come to our eyes? How does light come to our eyes? There are two kinds of objects as far as the properties of light is concerned. One object is luminous body, another is non-luminous body. Luminous bodies are those which have their own light, like electric bulb, candle, sun, tube light. Okay, they produce their own light. Okay, some objects are there, we think that light is coming from there, but actually light is being reflected. The objects which do not have their own light, cannot create their own light, okay, cannot produce their own light, and but reflect the light of other sources, are called non-luminous body. So light comes to our eyes in two ways, from luminous body from luminous body. Okay, light comes from luminous body. Luminous body directly to our eyes, and we can see those luminous bodies. If there is a candle burning or electric bulb glowing, we can see the bulb also. We can see the bulb, we can see the candle. That means the image of the bulb and the image of the candle is formed in our eyes. Even the sun also we can see. Sun is itself a luminous body, a candle is luminous body. Okay, and bulb is also luminous body. It produces light. We can see, in that case, light comes directly to our eyes and its image is formed. Okay. Second thing is light also comes to our eyes from a non-luminous opaque or transparent or translucent non-luminous bodies. How? Light also comes to our eyes from a non-luminous bodies. How? Due to reflection. Bodies due to reflection of light falling on them from some source. Suppose I can see this board. Okay, and I have there is light system in my room. The tube light is glowing. Tube light is the source of light, luminous body. From there light is coming, it is falling on the board, and light is getting reflected and coming to my eyes, and image of the board is formed. So I can see it. So board is non-luminous body, but then also light is coming from the board to my eyes. How it is coming? Due to reflection of light from the board. And this is the phenomenon which we will study in this chapter. Reflection of light. And due to reflection of light, we can see the objects. But not only this, without reflection also we can see the objects. For example, luminous body. If the light is coming from the luminous body, then its image is light directly comes to our eyes and its image is formed in our eyes. And for your kind information, image is formed in the retina of eye. Okay, and from the retina, electrical signals are formed. And then that reaches to the brain, and brain can interpret, and then with the help of brain we can see the objects. Okay, but we will not go beyond to that extent when we study about the reflection of light. Okay, so light is a form of energy that gives us a sensation of sight, and it helps us to see the things around us. And light comes to our eyes from two ways. Like it may come directly from a luminous body and from the image at our eye, and we can see the luminous body itself. And the second way is the light can come to our eyes from a non-luminous body also. But how it comes? Light gets reflected and then comes to our eyes. Okay, so we can feel this experience by switching off all the light of your room and make it dark, and try to see the things around you. You can't see the things around you because there is no light in the room. So what is going to reflect? And if the light does not reflect from the things around you and doesn't come to your eyes, then its image is not formed. So we cannot see in the dark. But as soon as we switch on the light and we can see the things around us, so that gives us a feeling. That gives us a feeling that to see the objects, either light has to reflect from that object or light has to directly come from the luminous body. Is that clear? Is that clear? Okay. So let me erase this and we will start the property of reflection of light. What is reflection all about? And what more we will discuss? Dual nature we have discussed. Light has dual nature. Okay. It has wave property also. It has particle property also. Particle nature. Okay. And this wave property is another segment of light, phenomena of light, and then particle nature another segment. Okay. There were scientists. A group of scientists used to say that light has particle nature, and a group of other scientists used to say that light has wave nature. So there was a fierce fight between them. Okay, and finally a great scientist came. His name I will tell you later. De Broglie. Okay, I'll tell you. De Broglie. De Broglie came in the later period during modern science, and he said that both the groups are right. This group of scientists and that group of scientists, they are correct. Okay, so don't argue between you. Okay, no need to argue. Light has both the nature. It has wave nature as well as particle nature. So that dual nature of light we will be seeing in higher class. So later on you will come to know that how light has dual nature, wave nature and particle nature. But in class 10 we will be studying only particle nature and phenomena of reflection and refraction and related terms. And also common observation in our everyday life based on reflection and refraction. Okay children, so I will erase this. Now we will write reflection of light. The first phenomenon of light in our syllabus, reflection of light. What? Reflection of light. Reflection of light. What is this? The phenomenon of light. Okay, the phenomenon of light in which a ray of light. For class 10 level we will just talk about ray of light. But actually light is not only ray. Please remember, light is not only ray. Light is actually wave. It is electromagnetic wave. Okay, proved by Maxwell. Electromagnetic wave, but when it travels from one place to another, then it has got a direction. And to show the direction, we draw a ray. In class 10 level, we will deal with ray of light. Maybe one ray or a number of rays. Okay, but we will deal with ray of light. So the phenomenon of light in which a ray of light bounces back after striking a surface. What kind of surface? Any surface. Opaque surface, transparent surface, translucent surface, Okay, some people might be thinking that how it is transparent surface. When we see the glass, window glass, we can see the things beyond the house also. Okay, beyond the window, that side. Okay, but and we can see the glass itself, the window glass also we can see, and we can see any if any person is standing outside the house, we can see from inside. Okay, but sometimes the glasses are so designed that sometimes only in one direction it is you can see. That is different thing, that is the different technology. But if you take a simple plain sheet of glass, you can see the glass itself, and you can see the things which are outside the glass on the other side. What is this? It means the light is getting reflected. Okay, and light is passing the glass also. Whatever light is there around me, that light is getting reflected from the glass surface. And if somebody is outside, then from there also light is striking the glass. Okay, and it is reflecting to that person, and even some light is crossing the glass and reaching to me. That means I can see that person who is the other side, on the other side of the glass. So light can reflect from any kind of surface, Yes, there are some rules. Sometimes light reflects in a regular manner, sometimes light reflects in scattered manner. That is different thing, but light gets reflected. Okay, reflected, bounces back to the same medium. I am standing in a medium, and I can see the wall. It means from the wall light is getting reflected towards me. That means I am standing here in one medium and light is reflecting towards me. In my room, light is there in my room where I am standing. Okay, and from this medium, light is striking the wall and again returning to the same medium. It is not crossing that side. Okay, so this is the phenomenon. The phenomenon of light in which a ray of light bounces back after striking a surface is called reflection. When we talk about bounces back, it means same medium. It's called reflection. Okay. Let me make you one thing clear, that when light falls on any surface, any kind of surface, whether plane mirror or curved mirror or opaque surface, whatever, any surface, it has three phenomena. Number one, reflection. Suppose it is transparent glass, just a glass. It is just a glass. Just a glass. Reflection. Number two, refraction. Number three, absorption. Take place. Reflection, a part of light gets reflected, so we can see the glass. Achha. And some part gets refracted in this direction. Refracted, it will change the path, that we will see later in the later part of the chapter. Some part gets refracted and some part gets absorbed in the glass. So if constantly light falls on the sunlight, I mean to say, or any source of light, even near that electric bulb, there is some heat. Okay, so if light falls on it, some energy, because they are supposed to be energy packets called photons. They are supposed to be energy packets called photons, and photons have some energy. That may be heat energy also. That energy gets absorbed here. So all the three phenomena take place. But when we study reflection, we assume that maximum light is getting reflected and we ignore absorption and refraction. Okay. And when we study refraction, we ignore reflection and absorption and we study only refraction. But all the things happen together. Okay. So we are studying reflection, so we will focus on only reflection. We are assuming that maximum light, all the light is getting reflected. What is happening, what is the other things happening there, we are not bothering about it. We just ignore. And when we study that particular thing like refraction and absorption, yes, we have to deal with that phenomenon also. Clear, children? So this is the definition, reflection of light. Now we will write types of reflection. Types of reflection. Okay. Number 1, regular reflection. What is regular reflection? What is that? The reflection of light from a surface reflecting from wherever the light reflects, it is called reflecting surface, and it is that surface is called reflecting surface. Okay, whether it is plain mirror, whether it is an opaque wall. Okay, so reflecting surface, the reflection of light from or reflecting from a surface in which a parallel beam of light parallel beam of light means like this, parallel rays of light, this is called beam. A parallel beam of light remain parallel after reflection is known as regular reflection. In this case, point number 1, in this case the reflecting surface must be plane surface. Plane, not uneven. It should be even. Plane surface or even surface. Okay. Diagram is, and in this case only laws of reflection is valid. Okay. Another type of reflection is there, which is called non-regular or irregular, or you can say scattered reflection. And in this kind of reflection, regular reflection, laws of reflection is valid. Okay, valid, but the other category of reflection, that is irregular reflection, and that happens most of the time, and we see the things around us because of irregular reflection, scattered reflection. Okay, regular reflection has very less use. Irregular reflection has so much of use. We can see the things around us, whatever we can see. This is all because of irregular reflection, scattering in different direction. You are standing in one corner of the room, you can see the photographs hanging on the wall. from any side, from any direction, you can see the same picture, same object you can see. Okay, but if you stand in front of your plane mirror, looking glass, in front of a plane mirror, you have to stand exactly in front of the mirror. Then you can see yourself, your image, isn't it? But if you stand at the corner or at the side and you want to see yourself, you can't see, because at that time there is regular reflection. Okay, and for regular reflection, you have to stand just in front of the glass. Otherwise, if you want to see any kind of table or chair placed in the room, from any direction you can see. You don't have to go exactly in front of the chair. So most of the things we see around us is because of irregular reflection. Okay, and regular reflection is only sometimes. But when we talk about laws of reflection, that is regular. In this case, the reflecting surface must be a plane surface or even surface. Okay. Now diagram. Suppose this is plane surface. For plane surface, you can draw a mirror. You know what is mirror? What is mirror? Mirror is a glass, plain glass. Okay. Mirror is a glass where one side is painted to block the passage of light, and one side is polished to provide smoother surface. Okay, so that regular reflection take place. Regular parallel beam comes and returns parallel comes, returns parallel. So these are slanting rays. Later on I will tell you the concept of slanting rays. Why not vertical? Then each ray will reflect maintaining the same angle. So we have to draw normal here. Normal, here also normal, and here also normal. Okay. Now this is the angle formed by the first ray with the normal. With the same angle it will return. This also will return the same angle. This is also angle. It is called angle of incidence, and this is called angle of incidence. The angle of incidence will be equal to angle of reflection. So it will return like this. Let me draw this parallel. You see, it has to be parallel. Okay. And if it is not looking parallel, your diagram is wrong. Maybe mine also is not perfect, but you can practice and make perfect. Parallel rays will come and parallel rays will return. Okay. So each and every ray of light is maintaining laws of reflection, maintaining the same angle. This kind of reflection is called regular reflection. To see the object due to this kind of reflection, you should adjust yourself in a proper position, because you are not expecting light in this direction. You are not expecting any light in this direction. Okay. It is unidirected, only in one direction. In what direction it is coming, and by maintaining the law of reflection, it will return in unidirection. So we have to adjust ourselves in a particular position to see the object due to this reflection, and this is not much used in our everyday life. Clear? Not much used. Maximum reflection that is useful and we can see the object around us is due to irregular. So what is irregular red sight? Second, irregular reflection. If parallel rays of light are incident on an uneven means rough surface, uneven surface. The reflected rays, boundary, reflected rays are not parallel. These reflected rays are scattered in different direction without maintaining any law. Such reflection is termed as irregular reflection. Actually, definition is written in the book, but what I feel is when I write the definition and I have got a scope to explain in each and every line, every statement. Okay, so this is the definition of irregular reflection, where parallel beam of light strike the surface, but it does not return parallel. While returning, they are not parallel. Okay. So now diagram. Let me draw a small diagram here. Suppose this is the uneven surface, like this, uneven surface. So parallel beam of light falling. Okay, in this way. So normal, they will not maintain the laws of reflection, but normal can be drawn. It will be like this. It will be like this. It will be maybe it is like this. So like this. See, these two are also not parallel. Parallel beam incident rays are parallel, but the reflected rays are not parallel. This is the definition. Irregular reflection, or it is also called scattered reflection. But most of the time we have scattered reflection, and then we can see the things around us. So these are the properties. There are two types of reflection. Now we will see reflection by a plane mirror. Then comes in our syllabus reflection through curved mirrors. So let me remove this. We'll write here reflection by a plane mirror. Okay. I have told you what is plane mirror. No need to write that definition. It's not that. The question will be, what is plane mirror? Write down. What do you mean by plane mirror? That kind of question that you have to understand. But if it comes also, you can write a plane mirror is a glass sheet having painted at the back side and having polished on the front side, and the rays of light are expected to fall on the polished side, and that polished side is called reflecting side. Okay. Okay, now let me tell you one inside story. Suppose this is a glass sheet. This is a glass sheet. Light is glass sheet, and I am telling you that the back side is painted. Backside is painted. Okay, backside is painted. So light will fall. When light falls, from where it will reflect? We are showing that reflects from here. We are showing that it reflects from here, but it's not the fact. It reflects from here. Tell me why. Ask me why. Light enters in this manner. Light does not reflect from here. Light reflects from here. Why? Because, and here actually light undergoes little bit of refraction, and that also we are ignoring when, as long as we are studying reflection. Okay, so light finally light reflects from this point. Why? That side is opaque, other side is opaque, it is painted, and front side is polished. So it will enter into the glass till the boundary between the transparent part and the opaque part. This is the opaque part. Opaque part. You can see in your house, like looking mirror is there. At the back you just see there are some kind of painting. Okay. So light actually returns from here. So what we draw only one line. The bottom line. This one. These two we draw. This we draw and we imagine that this is the mirror. Okay, this is the mirror. But every mirror has certain thickness. Okay, if you consider that thickness, then light actually returns from here, from the boundary between the transparent part and the opaque part. So, a plane mirror, provides regular reflection, okay, and forms virtual and erect image, of an object. What do you mean virtual? Virtual image means it's not the real. Understand directly. Virtual means it's not the real. Suppose a person, I just want to give one example, practical example. A person has driving license. Okay. His original driving license is at home. Okay, just one example, or somewhere. And whatever license he is having, that one is virtual. Means, what did you understand by this statement? What the police will understand? Virtual I-card or virtual driving license is not the real license. It's only for showing, only for making the people fool that yes, I have got this document, but original document is there. Okay, so from there you can take the instance that anything virtual is not the real. Okay, direct statement, anything virtual is not the real. Now the image that you can see in a plane mirror, when you see yourself, the image that you can see, is it real image? Can you take its photograph? No. Can you touch it? No. If you really go behind the mirror, can you see him? See your own image? No. It's virtual. It cannot be photographed. It cannot be taken into the film. Okay. That is virtual. Means not real. Not real. And if it is not real, if it is virtual, then it's always erect. Now what do you mean by erect? Erect means like this. See here. Suppose this is the object and its image is in the middle. There is a plane mirror. Plane mirror is there. This is the object and this is image. Maybe its size will be less or equal to, or in case of plane mirror it will be equal to, but in some other spherical mirrors it may be larger or smaller. That is different thing. But if the object is like this is the head, this is the bottom, tail, and image also, head is up and tail is down. If in this way image is formed, it is called erect image. Erect. Okay. But if it is inverted, the image will be seen like this. That I will discuss later on, not now. The plane mirror forms virtual and erect image. Clear? Have you seen my pen demonstration? Okay. This is the property of plane mirror object. So now you write properties of image formed by a plane mirror. Plane mirror. This we will do, and laws of reflection we have not done. I want to do in the middle part, laws of reflection. Let me finish the basic concepts about reflection. Plane mirror. Before we enter into spherical mirror, we will do laws of reflection. Properties of image formed by a plane mirror. What are the properties? The image formed by a plane mirror is virtual and erect. Number 2, the size of the image is equal to the size of object. You have studied this thing in lower class also, in class 8. Okay, the same thing we are studying in class 10. Size of the image is equal to the size of the object, and the distance of the image from the mirror is equal to the distance of the object from the mirror. That means the image will be as far behind the mirror as the object is in front of. You can write that also. The image is formed as far behind the mirror as the object is in front of. And I have written like this: the distance of the image from the mirror is equal to the distance of the object from the mirror. Number 4, the images formed by plane mirror cannot be touched or caught in camera. caught in camera or can be taken photographs. Number 5. But one thing will happen. If you see yourself in the looking glass, plane mirror, and if you raise your right hand, the image will raise left hand. The right appears left and left appears right. This is called lateral inversion. Not the vertical inversion. It will be erect only. Vertical inversion will not be there. You can't see your head down and legs up. You don't see. But you see your right appears to be left. It is called lateral inversion. The images have lateral inversion. Means right appears, only appears, it's not real, appears to be, it seems like that. Right appears left and left appears right. This is the 5th property. So these are the properties of image formed by plane mirror. You please make a note. Okay. Now we will practice how to draw the ray diagram to form the image of a point object and also the image of an extended object by plane mirror. Clear? I will remove it. Thank you. Understanding? Getting the concept? You should get the right concept about any topic. Okay. To get the right concept, please visit Right Concept Learning and like it, share it and subscribe it. Okay. So I will try my best to give the right concept on every topic. And detailed notes, detailed explanation. So, ray diagram to show the formation of image of a point object by a plane mirror. This is not there in the textbook. This is extended learning. When we talk about plane mirror, we should do this. Now plane mirror is this. Suppose plane mirror. What is this? Children, what is this? Plane mirror. Okay. Back side is painted, opaque. Front side is polished, reflecting surface. Now point object is here. Oh, point object. Object is very small. Point. We have to make image of this object. And as we know that the distance of the image formed is equal to the distance of the object from the mirror, and image is always formed behind the mirror. When we see the looking glass, we see our image behind the mirror. Okay. So how much behind? How much? Same distance. So let us draw a straight line, perpendicular line from here. First of all, perpendicular line. And think that this is also a ray of light coming from the object. I have told you earlier, from any object light can come, whether it is luminous body or non-luminous body. I have taken non-luminous body. Just a ball, suppose a ball is kept. Or you can place a candle also. If you place a candle, then the image of candle is formed. At that time candle is luminous body. Okay. So we take straight ray perpendicular to the plane mirror. Then same distance we have to maintain, same distance. But dotted lines, remember this, very important. Dotted line that side. because it's not going to happen really. It is virtually. Same distance, so it will be O dash. Image of O is O dash. O dash here. Now take another ray from here, any direction, doesn't matter, any direction. Because from object, a large number of rays are supposed to come out. Large number of rays. And one more important thing, that rays, all the rays of light are emerging out of the object. How? Because there is some source of light around it. Maybe here, maybe here, maybe here. Some source of light. From the source of light, it is falling, that source of light is falling on the object and getting reflected. Then entering into the mirror, again reflected. Clear? Like for example, if you make your room dark and stand in front of the mirror, you can't see yourself. Because light has to come from somebody, some source of light, and fall on it, and then again reflect. Okay? From here, it will reflect, regular reflection, plate mirror, regular, so we have to draw normal. Same angle it will maintain, same angle. It will be in this. It will be here. When the reflected rays come in this direction, we have to produce it backwards. And why to produce backwards? There is a strong concept. Suppose it is reflecting in this way. Oh, sorry. Okay. Angle of incidence is equal to angle of reflection. Angle I is equal to angle R. It has to be maintained here. Now, one concept is that image by plane mirror or spherical mirror, image is formed only when the rays of light meet once again after reflection. Please remember, please note down this line. Image of an object is formed only when light of rays meet once again after reflection. I will write down here. Image of an object is formed only and only when the rays of light meet once again after reflection or refraction. Meet means it may really meet, means directly, or it may meet virtually. Virtually can meet. Virtually means on producing backwards. How they meet? Rays of light, how they meet? They meet either really directly. They are returning, they are being reflected, returning, and they are meeting. Point of intersection. Or they are returning but no chance of meeting. Then they have to be produced backwards so that they appear to meet. It is very difficult to understand. Please follow properly. Image of an object is formed when rays of light meet once again. Meet or appear to meet. Okay. Meet or appear to meet. You can change. Rays meet or here, or appear to meet once again after reflection or refraction. That means rays of light can meet in two ways, either directly or virtually. Virtually means this side they are not going to meet, so they are produced backwards and they will meet. Okay. Do you know the concept of non-parallel lines? Are these parallel lines? No, these are non-parallel lines. That means, what is their name? What is their name? Name is intersecting lines. Can you see them intersecting? You can't. But if you extend in this direction, if you extend by dotted lines, if you extend, then they will meet. See? They can meet this way. But if you extend that in that direction, will they meet? They will not meet. They will never meet. See, like this. They will become choky. But this direction, they can meet here. But when they are, suppose they are returning in this direction, think, returning in this direction, they will directly meet. It will also come, it also comes and meets here. But if they are returning like this, one is returning like this and one is returning like this, will they meet? Will they meet really? Think, will they meet? They won't meet because they are getting widening up, recede away from each other. So they will meet, they will appear to meet if they produce backwards, if they are produced backwards, like this. Here they meet. Okay. Either they actually meet or they appear to meet. Then only image is formed. How image is formed? Learn it properly. When the reflected rays either actually meet or appear to meet on producing backwards, the image is again formed. The image is formed. So I have told you that when the rays of light, an image of an object is formed only and only when the rays of light meet or appear to meet once again after reflection or refraction. What is called once again? Once again means they have already met. They have already met somewhere. Where? At the object. Look here. Suppose a source of light is here. Get the concept, full concept. So suppose the source of light is here. So many rays are coming. So many rays. They are meeting here. All the rays are meeting here. Like this. Like this. They are meeting and getting reflected. So rays of light have already met here. Rays of light have already met here for the first time. And where are they meeting for the second time? That matters. Where are they meeting a second time after reflection or refraction? That matters. Here, if you take a straight ray, okay, then it will return through the same path. I have not shown you this one. When I showed that regular and irregular reflection, there is one more type of reflection that is called normal incident. Where I will draw? Normal. Okay. Suppose there is a plane mirror. In the previous diagram, we have taken slanting rays, right? Slanting rays. But now, I will take vertical, straight, vertical ray. Normal is here and incident ray is also here. Incident ray. Okay. That it is called normal incidence. Normal incidence means angle I is equal to 90. No, angle I is 0. Now it means the incident ray is making an angle of 90 degree with the mirror, not with the normal. Let me explain this one again. Suppose this is incident ray. There is a normal, and dash. Normal. Which angle is called angle of incidence? This angle is called angle between normal and incident ray is called angle of incidence. It's not the angle between the mirror and incident ray. This angle is not called the angle of incidence, or this angle is not called the angle of incidence. Angle of incidence is the angle between incident ray and the normal. And what do you mean by normal incidence? Normal means if this ray is turned and made like this, so it is normally falling on the mirror. That means along normal. Normal is this and ray of light is also this. Same line, angle 0 degree. Normal is this and incident ray is also this. So they are parallel. So angle is 0. Angle of incidence is 0. Normal incidence does not mean angle I is equal to 90. Clear? 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 Okay, clear. If it is normal incidence, then where will the reflected light go? What will be the direction of reflected light? It will be same. It will be along the same line but in opposite direction. It will just retrace its path. Retrace. It has traced once. Now it will again retrace. Okay. I went straight. Again return along the same line. Okay. Now this kind of thing you observe here. The ray of light from the object is falling normally on the plane mirror. Falling normally on the plane mirror. The way it will reflect along the same line but in opposite direction, which is called, it will retrace its path. Now it is retracing its path. That means this ray, this one is going in this direction, like this, and this one, ray number 2, this is traveling in this direction after reflection. So what is the case? This is going like this, this is like this. Look here. Will they meet? They won't meet here. They won't meet really. So how they will meet? They will meet virtually. Where? Produce them backwards. Tuck. They will meet. They will appear to meet. Because we have drawn dotted lines. Dotted lines is not real. It's virtual, just imagination. Okay, so this is the position of image of a point object. Clear? If it is not clear, watch the video again and again and listen to me again and again. So this is the formation of image by plane mirror when the object is a point object, and it is formed like this. This distance, suppose this is d1, this is d2, then d1 must be equal to d2. Okay, and property of image I have told you, it is virtual, erect. Clear? So we can form the image by taking a large number of rays also from the object, but only 2 rays are enough to show the point of intersection. So in how many ways these rays can meet after reflection? 2 ways. Either they will meet directly while returning. Understood what I am saying? They will meet really while returning, or they appear to meet when they are produced backwards. In both the case, image is formed. And when they really meet while returning, Real image is formed when they virtually meet or appear to meet by dotted lines, then virtual image is formed. So here the rays are the reflected rays are appear to meet. They meet virtually by drawing dotted lines backwards. So virtual image is formed. So we have already written that plane mirror formed virtual image. This is the reason why. This is the reason why virtual image. Now we will do extended object. Quickly. Extended object. Okay. Extended object. Extended object. It is not point. It is extended object. It is extended object. Suppose object is this. You can take a candle also. In your paper, a candle can also be given. I have taken non-luminous body. Non-luminous. Suppose my pen. Pen. I have taken a pen and I want to see the image formation of my pen behind the. What I will do? Simple. From the tail of the object, from the bottom of the object, I will take a straight line giving arrowhead in this direction, showing that it is falling normally on the plane, and as a rule we are not fool, so it will return through the same path. It will retrace, and while retracing it is going like this. Let us produce it backwards by same distance, like this, this and this. Okay. Tuck, 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 tuck. Tuck, tuck. Okay. Clear? You can measure with scale in centimeters. Okay. This is the position of image. Suppose this is A, this is a B. Then image of B is formed here. B dash. Image of B. Remember, each and every part of the object, image of each and every part of the object is formed here. Image of bottom B is formed here. Image of this point will be formed here. Image of this point will be formed here. Image of this point here. Image of this point here, and then join. Image, full image. Okay, but we will not do so long process. What we will do is, we will take a ray like this in slanting manner like this. Clear? Okay, let me erase this. The mirror has to be little longer. Okay. Now here is normal. Incident ray, normal. At the point of incidence, where is the normal? At the point of incidence. Suppose this is the mirror, this is incident ray, mirror, incident ray, and if you draw the normal here, is it correct? Is it correct? No. What is the rule? What is the use of this normal? This normal is not going to do anything. So we have to draw the normal at the point of incidence. Look at the point of incidence. At the point of incidence here, so that we will get angle of incidence. So it is incident here. So we have to draw a normal over here. Okay. And the same angle it will maintain. And return. But while returning, it will join here. So we have to maintain the direction. Let's not draw now. Let's take another ray from the head of the object and straight at right angle. And obviously it will retrace its path. This distance of the head of the object will be equal to the distance of the head of the image, this distance will be this distance. Tuck, 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 tuck. Oh, little less. Tuck, tuck. Okay. This is the head. Tail image is tail and head is head. This is a perchai. Okay. Size will be same according to properties of image formed, and distance also will be same from the mirror of object and image. Is that clear? Okay. Now this ray, this ray is returning like this, in this direction, like this. Okay, and this one is also like this. They are parallel. Can they meet? No, no chance, no chance. Okay. Now how this ray, this ray of light will reflect? For that, what we will do? It has come from the head. So returning rays, when produced backwards, must meet the head of the image like this. So you have to take one long scale and like this. Tuck, 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 ping. Like this. Okay. One straight line. It should not look like it is one, it is another one. Single, but here dotted lines and here straight line. So this is I, this is I. So if the object is this, you just shift the object and make the image at the same distance and then complete the rays. Suppose one ray is coming here, returning, produce backwards, another ray from the head coming here, returning, retrace, retrace, produce backwards. One ray is coming here, incident here, reflecting, okay, in this direction and produce backwards. Now think of this one and think of this one. This is going straight like this. They will meet. They won't meet. They won't meet really. They have to meet virtually. So this is the virtual image of the object. So this is D. If both are denoted by D, you can denote, okay, D, okay. D also D. Distance of the object from the mirror is equal to distance of the image from the mirror, and image is formed backwards, and it is virtual erect, equal size, image equal to A dash B dash, equal size. If its height is H, its height also will be H. Virtual erect, same size, same distance, but lateral inversion. What is lateral inversion? Let me draw here. Lateral inversion. Suppose you have written, you have got R here. This point image, top. Achha. Image of this point will be this point. Image of this point will be here. But this is quite far, like this. Here. And image of this point. Here. Tuck. Here. Okay. That means and image of this line will be here. means left appears right, right appears left. This kind of picture also you can see in the book. That another one, suppose L, it will be L. Size will be same. Size will be same. Suppose M will be same, and Z will be like this. Image of this is this, and image of this is this, maintaining an equal distance. And image of this is this. Image of this is this. Clear? So it is called lateral inversion. Okay, but this is minor things. You might have seen that ambulance written, that they are also the same phenomena, that lateral inversion there. That's why ambulance is written in opposite manner. Okay, so these are the basic things on plane mirror, and about reflection of light by plane mirror, and how image is formed by plane mirror, what are the properties of image formed by plane mirror, and how to draw the ray diagram and how to complete the ray diagram to show the image formation of an object, of point object and an extended object. Clear? So this ray diagrams you have to practice. In the next video we will be discussing on reflection by spherical mirrors, and this is the most important part of the chapter. So keep studying. Till the next video, all the best.